I wanted to just take a moment to kind of reflect on the past year in operational ML and talk about some of the interesting things that we're seeing, and also some of how that relates to some of the work we're doing at Tecton. It's been a really exciting year for operational ML. So we've seen we're really seeing a mass shift towards this kind of data-centric perspective for building machine learning systems, and that's great because that's really what this community is all about. And as this space matures, we're seeing new tools and abstractions that help make building machine learning pipelines easier and make it easier for teams to collaborate on ML projects. But at the same time, we're doing more complicated things, right? And so these more sophisticated ML projects bring more complex and advanced requirements for ML tooling. And so there's a lot of opportunity for new abstractions and new tools to make ML even easier, faster, and more powerful. So for example, just one example is, data engineering is still where the majority of the complexity lies when putting machine learning applications in production. And this is an area where ML specific abstractions is having a really big impact in making it a lot easier to do production ML. So I want to kind of just dive into that as an example and see what we can take away from that for the industry overall. So just a quick recap, we know models depend on features derived from the business's data to make good decisions. And there's still a ton of work needed to productionize even the simplest features today. So we've got to connect this data to these models. Even for the simplest feature, like a SQL query that we run against our data warehouse, there's a lot of work to schedule that, run that query against the data warehouse, take that data, load it up into an online key value store for real-time serving for model predictions, save it offline so it can be used for training purposes down the road. And this is just one architecture that someone has to design. But when you have your another feature in your model, maybe one that's like a time window feature that counts how many transactions has a user made in the past 30 minutes. Well, that might happen by aggregating over a data stream. And so that could be a totally different architecture. And often companies that are doing this, they have whole teams built to support each one of these architectures. If you're doing real-time features, if you're trying to extract, for example, like a feature from the search term that the user just typed in interactively into the website, well, you may need a totally other architecture, one that processes that data in real time. And so, different architectures are needed for different types of features. There's just a lot of data engineering work that needs to happen here. And each of these pipelines has ML specific requirements, right? You've probably heard of a lot of these. Probably a lot of you are working on different, a lot of us are working on different items here. Some big themes are, training, serving, skew, time travel, real-time serving. We've heard a lot of these things before. And there's not really one person that owns this stuff. Because these pipelines touch so many pieces of infrastructure and data science code, it's hard for a single person to manage them, let alone to build them. So one thing that's happening, across ML engineering broadly right now, it's a trend, is that new abstractions are emerging to help people manage these areas of complexity in their ML applications. So for example, for feature pipelines, it's becoming increasingly obvious that teams need a single abstraction over their features to help them manage the feature pipeline and all of its related infrastructure. And not just like a single feature pipeline, but all of the different feature pipelines that they have in their organization and across the whole ML lifecycle. And so this abstraction is something that we're super bullish about at Tecton and Feast. And we're going all in on this abstraction. So I don't think my slide is updating. Here we go. We're going all in on this abstraction. So we've built a unified feature management layer. So it allows teams to use a simple Python framework to define and register their ML features from these simple definitions, and then have their features be instantiated as productionized feature pipelines. And so the nice thing about this is that then with these new abstraction, we can provide standardized APIs and tools to make these features really useful, right? So to manage and govern these features, to productionize and deploy them, to access their data in a standardized way, to create derivative data sets for model training or model serving, and stuff like monitoring to ensure they're correct over time. Again, this is about creating better interfaces to manage features, not about forcing a specific data tooling under the hood. And so that's why it's really important that all of this operates on top of your existing cloud data infrastructure. So these new ML ops tools that we're beginning to see are not going to be black boxes, but they're going to sit on top of or in your existing data environments rather than introducing a whole variety of new data tools. So in this case, you can have one feature that will be defined potentially, running SQL against your Snowflake, and another feature that can involve running a Spark job against your data lake. And they can be managed in the same way through the same interfaces and also even used in the same models. So this feature platform is a great example of a new abstraction providing ML specific interface that hides a ton of complexity from engineers and data scientists to make their lives easier. And so when using stuff like this, teams get to production faster, they collaborate better, but they also get some other cool stuff. Like they get like the best practice in architectures, for free out of the box, right? And so that kind of saves them time and money, but they also just get much nicer engineering and development workflows, which makes their jobs a lot easier. So this new generation of ML tools is bringing standardization where it didn't previously exist. So this allows for greater decoupling in the machine learning stack. And this really brings like a lot cleaner ML architectures. So for example, with the feature platform, other tools in the ML stack now have a standardized way to access feature data. Tecton offers this through a REST API and Python clients, but this increased pluggability is a great thing for ML teams, and not just for these types of platforms. So these new ML abstractions, they really come from teams that are getting their hands dirty, doing this kind of costly shadow engineering work needed in every ML application. So they're the people who are like building ML applications day to day. Fortunately, these teams are the ones that we're going to be hearing from today. The talks today hit on a lot of emerging ideas that are making production ML simpler and easier. And it's an awesome look at what some of the best applied machine learning teams are doing and are developing really to help them run ML effectively in production. So we're super lucky to have an awesome set of speakers today. And I'm thankful to all of them in advance.